And what I mean by special cases is this. You know how to do 95% of the problems. 95% of the problems you just do. You just double distribute. You get your answer, and nothing special really happens. But then there's 5% of the time probably where you're like, okay, something weird just happened, and I don't know exactly what that means. But so these are called special cases, and there are two special cases where certain things happen, and you're gonna like special cases. You know why? Because it means shortcut. It means I don't have to show my work. It means as soon as I recognize this problem, I'm going to go, oh, that's special case number 1. Here's my shortcut. Boom. So let's talk about that one. Let's do special case number 1. And they actually call these special cases, meaning sometimes this will happen. And when it does, if you can recognize it, you'll be able to do a shortcut. So before I tell you the name of it, I'm going to do a couple, and your goal is to see if you can figure out what makes it so special and what the rules are going to be for that. So if I ask you to multiply an x plus 5 times an x minus 5, so just let me do a few of these. So something weird's going to happen, okay? So I'm going to distribute the x times the x and get x squared. Then the x times the negative 5 and get negative 5x. Then I'm going to distribute the positive 5 and get positive 5x. And then I'm going to distribute the positive 5 to the negative 5, which is negative 25. And so if you noticed yesterday on your binomials, you realize that most of the time it ended up being the two terms in the middle that had to be combined, right? And then the ones on the end just came down, and that's the case here. There are no other x squareds, but there are two x terms, and they happen to do what here? Yeah. So they're gone. So now the dilemma is, what do I put? There was an x in the problem. Does that mean I have to put an x in the answer? No. They're gone. Don't put any x term at all. You have your x squared term, you have no x term, and you have your constant. And the answer to that is just x squared minus 25. Okay? I'll do another one. See if you can pick up on this. A minus 10, a plus 10. This time I'll do box method for you boxers out there. So here's my box method, an a minus 10 and an a plus 10. It's still going to give me my a squared. It's going to give me my positive 10a. It's going to give me my negative 10a. And then my negative 10 times my positive 10 is going to be negative 100. So it happens again. The negative 10a and the positive 10a cancel, and I get that as an answer. Let's do a couple more. I'm going to kick this one up a little notch here, so I'm going to give a coefficient to this. So let's take 2x plus 7 and 2x minus 7. So in a minute, I'm going to ask you to see if you can kind of figure out what this rule is. 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. And now I go and distribute this. And there's that positive 14x. And I want you to think about this. A positive 7 times a negative 7 is going to be a negative 49. That sign right there is going to come into play in a little bit. Okay, so again, I go to combine these two and they end up canceling. And I have 4x squared minus 49. I'm going to do one more, and then I'm going to ask you if you are seeing something happening here. Okay, so let's take 3a minus 8b and a 3a plus 8b. We'll keep it even. I'm seeing a lot of people liking to do the box method, so you know what? That's good. It's making me do it more because I'm so used to the double distribute. So I have 3a minus 8b, 3a plus 8b. So let's go ahead and fill that in. Okay, yeah. Am I going too fast? I'll give you a minute to catch up. There's your positive 24. I know you can't add a plus b, but you can multiply unlike terms, right? That's just ab. And then here is my, this is going to give me my negative 24ab. And then what's this going to give me right here? Negative 64b times b is b squared. And so this answer, 9a squared minus 64b squared. So let's stop with the examples right now and just kind of go back and look at what we have. And let's try to kind of figure out some things. I'm going to get a highlighter, and I'm going to highlight some numbers here. And you're going to tell me what all these numbers have in common. Oh, I should have highlighted this. 4, 49, 9, 64, 100, 25. All those numbers, you know what kind of numbers they are? They're a very special set of numbers that you are going to use a lot this next unit. And if you don't know what they are, I'll give you a hint. Join me when you figure out what the next number should be. No. Why? It's freaking me out. They just said you keep hearing whispers. That's like, okay, no, I don't, no, it's not me. Maybe it's the vent. Move away from the vent. What's next? 49. What's next? 64. Then? 81. 100. 121. Anybody still not with us? Okay, 144, and that's usually about where it stops. But before I show you the next three, where in the heck are these numbers coming from, and how were they like reading my mind? No, these numbers are what? They're a very special set of numbers, and they're called and they're perfect squares. So they're called perfect, well, get rid of that. They're called perfect squares because I got them by squaring the first 3 squared, 4 squared, 5 squared, right? Got it now? So 7 squared, 8 squared. So I just took the first 12 whole numbers and squared them. And usually we have to memorize up to our 12s, right? But I'm going to get you up to 15. So we're going to kind of learn 13 squared, 14 squared, and 15 squared. And you kind of tuck it away in your mind. Use it when you need to. So 13 is easy because if you think of 3 and you think of the multiples of 3, the next multiples of 3 are 6 and 9. So 3, 6, 9. So 13 times 13. And for 14, you just flip those around and you get 196. So the same 3 digits are used. And 15 times 15 is 225. However you want to kind of keep that in your head, just think 5 ends in a 5, 1 plus 1 is 2, whatever. Okay, so those are, we're going to go up to 15. Obviously, 20 times 20 is 400. 400 is a perfect square. 256 is 15, or 16 times 16. So these numbers, when you see them in the special cases, are going to be like big flashing neon signs that tell you, oh, this is probably a special case coming up. So I want you to look at every single one. And was 1 on the list? Yes. So 1 on the list is a perfect square. It's our first one. Okay, I'm going to also give you another list of perfect squares. And you may not think this, but x squared is a perfect square. X to the 4th is a perfect square. X to the 6th, x to the 8th, x to the 10th. What do all these have in common? They are even powers. And the reason I can say that is because I got x squared from doing x times x. And I got x to the 4th by multiplying what? Right? And what did I get by to multiply x to the 6th? X to the 3rd times x to the 3rd. And x to the 4th times x to the 4th. So only even powers are perfect squares. Okay? I know what you're thinking. Like you could say, well, if I were to take x to the 5th, isn't that x to the 2.5 times x to the 2.5? For our purposes right now, we're not dealing with fractional exponents. That's an Algebra 2 lesson you're going to learn about. We haven't done an exponent that's a fraction yet. There's an easy thing to it, but you just got to know it. So right now, you can only take even powers as perfect squares. So not a perfect square. Okay? So, keeping that in mind, let's go back and figure out how perfect squares come into play. So, first of all, what else do you notice about the sign in the middle of all my answers? Every single answer has a negative in it, right? Okay? So, I'm going to tell you what the name of this is, and you're going to read it, and it'll make sense to you. Special case number 1 is called the difference of two squares. Difference of two squares. Think about what that means. The difference means minus, right? So it's the difference between the square of the first one and the square of the second one. But how can I use a shortcut here? So for example, let's say this. Here's the definition of a perfect square. If I take a plus b and multiply it by an a minus b, did you notice that about all the problems? They were almost identical, except one always had a plus and one always had a minus. Did it matter which one went first, the plus or the minus? No. Multiplication is commutative. Here's the only time, ever, that the difference of two squares will work. When you have almost identical parentheses, both are a's, both are 10s, 1 plus, 1 minus. Both are 2x's, both are 7s, one's positive, one's negative. Got it? Okay, if that's the case, you know what you can do to skip this whole step? Because you know they're going to cancel. So watch. You're going to take the first number and square it. Then you're going to take the second number and square it. And you're going to make sure that you have a minus in between it. That rule applies for every single difference of two squares that you do. Okay? So, for example, let's try to do a couple of these problems without showing the work. No box method. No double distribute. Not often that your teacher tells you, I don't want to see your work, right? So right now I want to see if you can apply that shortcut to this problem right here. 11a plus 6, 11a minus 6. You know that middle term is going to cancel because they're almost identical. One's positive, one's negative. So what is this answer going to be? 11a times 11a is? And a negative 6 times a positive 6 is a negative 36. Got it? Okay. So, the next hint is, what should this sign always be if there's one positive and one negative? It's always got to be a negative. So, in the difference of two squares, it'll always be a minus, which is really a negative, right? It's you know that it's not the middle term. It's the sign for the last term is what it is. Okay, so now try this one. This one gets a little crazy. 15x squared minus 3y. 15x squared plus 3y. It looks crazy, but just apply the same concept I just taught you. So go ahead and just try to put an answer. Answer only. Now it's JC that's whispering.
Okay, but...
Creepy. Are you hearing voices? Stop. Okay, so 15x squared, and then 3y. You just wrote it down about 5 minutes ago. Careful, what do you have as an exponent here? Yes, because when you multiply, and here's another way to look at it, 15x squared. Isn't that power of a power? Doesn't that mean 15 squared? And 2 times 4 minus 9y what? Squared. Okay? Think you got it? Yes. All right. That is the difference of two squares. Special case number 1. Check. Pretty easy, right? Okay. 2. So now we only have one more to do. So special case. Nope, just 2. Number 2. This one is a little more involved than the difference of two squares, but that's okay. It also involves square numbers. And the difference here is that instead of an x plus 5 and an x minus 5, it's an x plus 5 and another x plus 5. Meaning they are identical. Meaning you may not see them written like that. You may see it written, actually, not you may, you will see it written like that. Doesn't that mean the same thing? Okay? So this one's a little harder to figure out. So I really want to see who's with me and kind of go with me and figure this out here. So let's do like we did before. Let's just go ahead and double distribute and kind of see what we end up with. So I still have my x squared. Then I have my x times positive 5. And now on the last one, this is where it canceled, right? But it doesn't cancel. I have a whole nother one because I have another 5x. And what's my end term going to be? Positive 25. Okay, so now they don't cancel. Bless you. They, say it again. What's the word you said? Oh, okay. I didn't realize that because I heard the word because I couldn't get anybody else to say it. Instead of canceling, they are more than just combining. When you add a number to itself, don't say squared. You have, and what's another way to say times by 2? You have $10? Double it. Thank you, JC. You win the prize. So x squared, I just took that 5x that canceled in the last one, and instead of cancel, I doubled it, and I got 10. Okay, that was our first one. I'm going to do another one. This, what's that?
I'm really confused that, that's what we've been doing.
What's that?
That.
That's what you've been doing the whole time, right? It's just, that was a 6 before. I've never given 2 to you where they're the same. It's the same process. So what you're saying is, didn't we do that before? Yeah. But here's what I'm saying. The ones you've been doing before, there was no shortcut for. There's a special case where you're not going to have to show this work. You're going to be able to go right to it. But I want you guys to figure it out. So how about this? 4x plus 3 times 4x plus 3. Okay? We'll box this one out. So you have a 4x plus 3 times another 4x plus 3, which is going to give you, go ahead and fill it out with me, 16x squared. Here's one of your 12x's. Here's another one of your 12x's. And then 3 times 3. There's that square number again. Okay? And both of those are on that magic number list, right? Well, no duh, they are, because I got them by multiplying a 4 times a 4 and a 3 times a 3. So then my final answer is 16x squared. They're both positives, so it's plus 24x plus 9. Do you think you can give me the way to get that middle term? So, watch. Let's just talk about this. Obviously, I know how I got the 16 and the 9, right?
Yeah.
I squared the 4x. I squared the 3. The key is, how the heck can I come up with a shortcut? And it has to do with the 4 and the 3. And it has to do with something doubling. And it has to do with some multiplying. I know you're like, ooh, now you just got to put it all together. Yes. Yes. Go ahead, JC.
I would say you multiply the two.
Yeah.
And then double.
Yes. So he said, well, I know that if I multiply 4x and 3, I get 12x. And then Austin said, take that and double it. Isn't that 24? Yeah. Let's go up here and see if it works for this one. What's x times 5? 5x. What's that doubled? Not squared. That's the most important thing. Don't square it. Double it. 5 plus 5 is 10. Let's do it for another one and see if that works. Let's take 3a plus 5 squared. Okay? Meaning I don't want to write it out because I don't want you to be tempted to do the double distribute. I want you to try to use the shortcut. So I want you to say that you know that the first term is going to be a 9a squared. You know that the last term, and I want to talk about this last term. Remember how up here I told you that this always had to be a minus there? Well, if you're squaring a number, what do you think this end sign always is going to have to be? Yeah. I better not ever see that end sign anything but a positive. Because what's a positive times a positive? Positive. What's a negative times a negative? Positive. So I'm going to do one with you in a minute with a minus. So you know what this is? Plus 25. And how can I get that middle term right here? Because the ends are easy. 3a times 5. A. And doubled is positive 30a. Without any work shown. Okay, let's do another one. And then in a minute I'll give you the name of special case number 2. Okay, let's try this one. Let's do 5a. Let's do 6a. We haven't done a 6. 6a minus 4 squared. So 6a times 6a is 36a squared. Negative 4 times negative 4 is a positive 16. Yeah. What's 6a times negative 4? That's kind of important that you put that negative up there. Because if you have two negative 24a's, you have a negative 48a, right? Look. So this sign of this goes with whatever sign is there. So the middle sign for this term is whatever sign you're given, and the end will always be a plus, right? Okay. The name of the, well, let's just do one more. I'll give you one more and see if you can figure it out. 7x minus 3y squared. See if you could do that one. Square the last, multiply them together, double, then you have your answer. Okay, they got it? It's kind of tricky because I threw another variable in there, right? But that's okay because look, I'm still going to have 49x squared. I'm still going to have a positive 9y squared. And what is 7x times negative 3y? And if I have two of those, I have a xy. Good? Okay. What if I had a cubed right here? What if I had 10a cubed minus 6? Just do that one. 10a cubed minus 6. Got it? Okay. So the name of this special case is called a perfect square trinomial. You'll see it PST, perfect square trinomial. And as soon as I give you the little rule for that, that means if I have a plus b squared, meaning there are two of the exact same parentheses, I square the a, I square the b, this will always be a plus, right? And now, what I did to get the middle term was I multiplied a and b together and then doubled it. And whatever sign is given, that's the sign that goes there. Right? So that's always a plus, and whatever's given is that exact sign. So you know what that means? I got to do another one for when it's a minus. And then we're done. This just means take your a and square it. This is always a plus, right? Because negative times negative is positive. Multiply your a and b together. Double it, except now, whatever sign is there goes there, okay? All right, here's the deal. They're not so bad when I give you a whole sheet of special cases number 1 and then a whole sheet of special cases number 2, but this is advanced algebra, so I'm jumbling them all up. So one might be this one, and the next one you do might be the next one. You have to be able to train yourself to know when to do which one. So separately, you guys would probably rock it. I mean, you might rock it when they're together, but you might have to really go, ooh. So you know what I had some kids do? They said, I'm going to go through and do the whole special case number 1 first, right? And then get those out of my brain, and then I'm going to do the special case number 2. So however you want to do it,